Alright everybody, we are on to chapter 4. We're no longer just learning about angles and lines and that kind of stuff. We're actually starting with some shapes now. In this chapter, we're going to be focusing on triangles. Alright, this entire chapter. Actually, this chapter and the entire next chapter, both going to be about triangles. There's a lot to learn about them. And in this section, which is called Applying Triangle Sum Properties, there's going to be two things that we're going to learn about triangles, the most basic things that we can learn about them. In this video in particular, goal 1 is what we're going to cover, and that is that you will classify triangles by angles and sides. So these are things that you've heard of before. You've heard of isosceles and scalene triangles and acute, obtuse, right triangles, all those things. That's exactly what I'm referring to when I'm saying that you're going to classify angles, or triangles, rather. Alright, well, let's get on to it. Two different groupings. You can classify a triangle based on how long its sides are in relation to one another, and you can classify a triangle based on what the angle measures contained in the triangle are. We're looking right now at classifying triangles by sides. And so what I need you to notice here are the differences between these three triangles, and look at the markings that I've made here. In this first triangle, you're going to see that there's a different number of tick marks on each side length, which indicates each of the three sides is a different length. On the second triangle, I'm indicating to you that these two sides are equal in length, and this one's different. And in the third triangle, I'm indicating to you that all three sides are the same length. Alright, you probably already know these things, so if you do, go ahead and write in the classification for these triangles. If not, watch. First, let me write down what we've already stated, but in different terms. I said the first triangle has no congruent sides. And then the second and third triangles have two congruent sides, and then three congruent sides, or all sides congruent respectively. Okay, now if a triangle has no congruent sides, that is called a scalene triangle. Right? And then of course, I believe you're familiar with the fact that if a triangle has two congruent sides, it's classified as isosceles. And finally, whenever all the sides of a triangle are congruent, or all the sides of any kind of polygon for that matter, it's classified as equilateral. Easy, right? Okay, just one more thing I want to tell you about this, because truly, isosceles triangles by definition don't have to have two congruent sides, they have to have at least two congruent sides. Meaning that an equilateral triangle can also be called isosceles. Let me write that word at least here, or that phrase at least, in regards to isosceles triangles. Alright, so three ways of classifying triangles based on how many congruent sides they have. Alright, now we want to look at how you classify triangles by using their angle measures. Now, what I've got here are four triangles, because there's four different classifications we can have. In this first triangle, you're going to see that the angles, well, all of them are less than 90 degrees. I think you can tell that because there's no right angles, right? Everything else is less than a right angle. In the second triangle, you've got one right angle and the other two are less than 90 degrees. In the third triangle, you've got this angle right here, which I hope is clearly bigger than 90 degrees, so it's obtuse. And here, not only are all the angles acute, they're also all equal to one another. Each of those yields its own classification. Now let me write the descriptions and then the classification for each one of these for you. Alright, so what I said a moment ago is that all the angles in this first triangle are acute angles, and when all the angles in a triangle are acute, it's called an acute triangle. Alright, in the second triangle, there is one right angle. Alright, now you might wonder, how do you classify this if one of the angles is a right angle and the other two are not right angles? Because it took three acute angles to make an acute triangle, right? But with right angles, if you have one of them, that makes a triangle a right triangle. In fact, it's impossible, since a triangle has 180 degrees, for a triangle to have more than one right angle. Alright, so if it has just one right angle, that makes it a right triangle, which you knew that already. And similarly, If a triangle has one obtuse angle, then it's going to be called an obtuse triangle. It would be impossible for a triangle to have more than one obtuse angle because the triangle has to have 180 degrees again. Alright, then finally, let's say that all the angles in a triangle are congruent to one another. Well, they would each have to be acute angles first of all, so we could classify that as acute, but that's not the way we're going with this. It's not the most precise classification. If all the angles in a triangle are congruent, just like all the angles in any polygon, we go back and we use a word that we learned in chapter 1. We're going to classify that as an equiangular triangle. Hopefully you guys remember those terms: equilateral, equiangular, and regular. Anytime a triangle is equiangular, it happens to also be equilateral, and so this could be classified as a regular triangle as well. Those are the ways of classifying triangles by angles. You've learned the ways of classifying triangles by sides. Do a couple of very simple examples here where we're going to apply each of those things. I'd like you to go ahead and classify each triangle by its sides and by its angles. So you're going to give two names to each of these triangles. Maybe you call this first triangle an acute isosceles triangle. Maybe you call this second triangle an equilateral obtuse triangle. All right? Just throwing out, you need two names for each of them. Go ahead and name each triangle, please. All right, in part A, let's look at the side lengths first. You notice that each of the three side lengths is different. And if none of the side lengths are the same, then you can classify the triangle as scalene. So it is a scalene triangle, but we can also classify it based on its angle measures. You see that it has an angle that's more than 90 degrees, and so that's an obtuse triangle because it has one obtuse angle. So you call that a scalene obtuse triangle. Yeah, that E doesn't look any better. Oh well. All right, second triangle. It might look a little bit weird that this side length has a radical attached to it. Don't worry about that. What's important here in terms of classifying this by side lengths is that these two side lengths are both the same. And if a triangle has at least two congruent sides, then you classify it as isosceles. Alright, and then is it acute, obtuse, or a right triangle? Well, it's got a right angle, doesn't it? So that would be an isosceles right triangle. Very simple, right? One more set of examples here. And this time, I'm going to give you the classification, and you're going to draw the picture. I would like you to draw the indicated type of triangle, an isosceles acute triangle, and a right scalene triangle. And I want you to use some markings to make sure it's very clear which kind of triangle you're drawing. Go ahead and attempt this, and then you'll see the way I'll mark it to make sure it is clear that the triangle is the type of triangle that we say it is. Well, in order for a triangle to be isosceles, it's going to have at least two congruent sides. And in order for it to be acute, none of the angles can be 90 degrees or more. So that's kind of the challenge here. I'm going to put one up here on the screen for you. Now, in terms of how you mark this, I would like you to show me that you have two congruent sides, and let's just say that it's this side and this side that are congruent to one another. And I'm just going to put little dashes on there, making sure to indicate that those two sides are congruent. That's good enough to make it isosceles. And then as far as making it acute, well, if you can make it so that it's obvious none of the angles are 90 degrees or more, that's acceptable. Sometimes in your attempt to draw a triangle, you don't actually get everything the way that it's supposed to be, but I'll still let you label it using, say, some angle measures. Like maybe you say this is 70 degrees, this is 70 degrees, and this is 40 degrees, for instance. That would be a way of indicating to me that everything is an acute angle, and so that's an isosceles acute triangle. All right, then for a right scalene triangle, obviously, you've got to go ahead and draw a right triangle, make sure it has a right angle. And then for the scalene portion, you need to make sure that none of the sides are the same length. That could be something like this. Again, sometimes it's hard to make something look exactly the way you want it to. It's possible you could try to be drawing a scalene triangle, but the two sides right here might look like they're the same. And if you will go ahead and mark using dashes like that these are different lengths, that'll make it clear that you're trying to make this a scalene triangle. And then as far as a right triangle, of course, you're just going to go ahead and put that right angle marker where the right angle is. That makes it a right scalene triangle. Very simple to classify triangles. You should have this down already, truly. Thanks for watching. Make sure you see the next video for section 4.1.